Right, so we're continuing on with the chapter 1.4 notes. I'm looking above example 2 on the third page. I'm going to be sticky notes here. I just want to remind you about those two different patterns that we had from the last section. We had the difference of squares, which said that if you have an a squared minus a b squared, it will always factor to a plus b times a minus b. We also had that perfect square trinomial. We had like two different versions of that. You can think of it as the positive version, which was a squared plus 2ab plus b squared, will always factor to be a plus b squared. And a squared minus 2ab plus b squared will always factor to be a minus b squared. So if we look at example 2, we're going to factor using these special patterns. And really it's the same as what we've done before. It's just that now our a is going to have two parts to it. So part A is difference of squares. And I would label here my a. Remember, if you have that perfect square chart, that might be helpful. A is 3x, and my b here would be 8. So difference of squares always just factors to a plus b times a minus b. So it'd be 3x plus 8 and 3x minus 8. Part B, this is a perfect square trinomial, and it's our positive one. So I'm looking at the first part and the last part. Here my a would be 2y, and my b would be 5. And this will always factor as a plus b squared. So it would be 2y plus 5 squared. As a reminder, in your Go formative, you would enter this as 2y plus 5, and then it's called the caret button, but it's that triangle. I think it's shift 6. Part C, same thing. This is that perfect square trinomial, but this is like the negative version. So I'm looking at my first and my last term. My a here is 6w. My b doesn't look like a perfect square, but remember 1 is actually a perfect square. B would just be 1. So when we factor this would be 6w minus 1 squared. So that's using these special patterns, which, like I said, if you know these, it makes factoring really easy. We also have this thing where we can factor out monomials first. So if we look at this first part, factoring out monomials is kind of like factoring out greatest common factors. So this first part, I'm going to factor out a 5. And when you factor out a 5 from here, it doesn't just vanish, it just goes to the front. And we're left with x squared minus 9. And then maybe you notice this is the difference of squares. So by factoring out that monomial, we're able to then use our special pattern here. So then this would become 5, and then x plus 3, x minus 3. Again, that just comes from that a plus b, a minus b. Part B, if I want to factor something out here, I could factor out 2, not 2, crazy, factor out a 3. So I'm left with a 4, 3, and then 4p squared minus 7p plus 1. And now when I try and factor, I'd have 4 times 1, which the factors of that would be negative 1, negative 4, negative 2, negative 2. Notice my factors aren't going to add up to negative 7. So by factoring out this monomial first, I see that this can't be factored any further than this. It would still be wrong if you just left it as the original, but it's right by factoring out that 3. I want to add another example here, just so that you can see how this would look also going through the whole process. So 6x squared minus 14x plus 8. Here, if I factored out a 2, I'm left with 3x squared minus 7x plus 4. And then I can factor by grouping as normal, so this would be 12. To add to negative 7, my factors will be negative 3 and negative 4. Sorry, not a ton of room here. So when I rewrite this, it's going to be kind of crazy with the parentheses. So if you are feeling brave and you want to drop that 2 until the end, you can. Or maybe you want to use brackets instead of parentheses, because we're going to have a lot of parentheses suddenly. So I can rewrite this. I'm going to split my b term into minus 3x, minus 4x, and then I have my original. So this would factor, here comes all those parentheses. I can pull out a 3x, and I'm left with x minus 1. Here I can pull out a negative 4, these are my two groups, and I'm left with x minus 1. So my matching factors are here. So I have 2 times x minus 1, and then my other factor is that 3x minus 4. Okay, so that one factored nicely when you factor out that 2. Just be aware that you're going to have a lot of parentheses then. Example 4. So don't forget, our whole goal here is to actually solve these quadratic equations. And by solving, we're saying we're finding the roots or the solutions or the x-intercepts or the zeros. So here's another thing. I decided I want to do more with the story problems and the word problems tomorrow. So erase example 5 because we're going to do multiple examples like example 5. Actually, we're going to do example 5, but later, and I want space to do more of these just solving equations for now. So to erase that, you just click on the pencil, make it white and really big, and then that will just, you just draw over it. So we're going to add a c, and our c will be 3x squared minus 3x equal to 0, and my d is going to be 12x squared plus 7x plus 2 equal to x plus 8. Alright, so remember there's a couple ways I can ask you to solve for your roots. I can set it equal to 0, and then you're expected to solve for 0 after you've factored. I can also ask you, okay, here's a function standard form, put it in vertex form so that you can, or I'm sorry, intercept form, so that you can find the roots or the solutions or the zeros. So if we look at part A to start, just think factoring by grouping here. There's no common monomial that I can factor out right at the beginning. So I'm just going to go ahead and multiply these. So I have negative 24, negative 1 and 24, negative 2 and 12. So negative 2 and 12 gets me to positive 10. So I'm going to write this as 3x squared minus 2x plus 12x minus 8 equals 0. First two groups, my second two group. So from this first one, I can only pull out an x. So I'm left with 3x minus 2. From the second one, I can pull out a positive 4. So I'm left with 3x minus 2. I have a repeat parenthesis. And then my other factor is what's left. So now here's the new part. I have another step here. I'm going to set each of these equal to 0 separately. So now you have to do some arithmetic here. We're going to have to add 2 to both sides. We have 3x equals 2, then divide by 3. For your Go formative, please leave all of your answers as fractions, because oftentimes these are repeating decimals, and I don't have to worry about how to enter those. So leave them as fractions. This other one would be x. You'd subtract 4, so x equals negative 4. So those are our two solutions here. Looking at part B, so for part B, before I even begin, notice that I can factor out 5 from all of these. So I'm going to go ahead and divide 5 out. That's factoring out a monomial before you even start. So then I have p squared minus 4p plus 4 equals 0. And by doing it this way, I don't even have to factor by grouping now. Now I can just factor our old-fashioned way where we list the factors of the last number, and we find the ones that add to that middle number. And in this case, it'd be negative 2 times negative 2. So I'd have 5 times p minus 2 times p minus 2. And this is also actually a perfect square trinomial too. Sort of multiple things all at once. So it gets a little redundant here because it's not really necessary to set p minus 2 equal to 0 twice, right? Because you're going to have the same answer here. So really, your solution is just p equals 2. Notice that 5 in front doesn't change that at all. So if you did drop it, it wouldn't be the end of the world, but it wouldn't technically be correct when you're saying that these are equal to each other. Alright, so for part C, again, I can factor out, before I even start, I'm going to factor out a common monomial here. And in this case, I can actually pull out a 3x. So then we're left with x minus 1. And here, no factoring is required. Remember, when you have something equal to 0, if you have two things being multiplied, it's true that either one thing is 0 or the other thing is 0. And in this case, we don't actually have to factor to set these equal to 0. So then we'd have x equals 0, because I'd divide by both sides by 3, or I'd add 1 to both sides, and I have x equals 1. So that one's tricky in that it is so simple, and we're used to seeing more of a process for these. Finally, part D. So part D, we're not in standard form, so we can't jump to factoring and putting this in intercept form. So before you ever solve for 0, or before you ever factor, you need to make sure that you are fully in standard form, which means that you have all of your x's, all of your numbers on one side, and then you have a 0 or a y on your other side. So to start, I'm going to subtract x from both sides, and I'm going to subtract 8 from both sides. I'm going to do this in one step. So then I have 12x squared plus 6x minus 6 equals 0. Okay, so it's important to always have this in standard form before you solve or before you factor. Once I have it here, again, I'm going to notice that I have a common monomial happening. So I'm going to actually factor out a 6. So then I'm left with 2x squared plus x minus 1 equals 0. From here, I can factor by grouping, so negative 2. So, factors of negative 2 that add to positive 1 would be 2 and negative 1. So when I group these, I have 2x squared plus 2x minus 1x minus 1 equals 0. First two and second two terms. So from the first two terms, I can pull out a 2x, and I'm left with x plus 1. From the second two, I can pull out a negative 1, and I'm left with x plus 1, all equal to 0. Again, we're kind of going crazy with the parentheses, so maybe if there's another way you want to write this, do whatever works for you. My repeated factor, and my other factor. And then I just set things equal to 0. I don't need to set 6 equal to 0 because that doesn't make sense. In fact, you could divide both sides by 6 and the 6 would just be gone. So then all I have is x plus 1 equals 0, or 2x minus 1 is equal to 0. So x equals negative 1, or if I add 1 to both sides, x equals 1 divided by 2, I get that x equals 1/2. So that's basically solving, and we now know how to factor and solve multiple kinds of equations with quite a few different methods. So your practice runs through this. It's lots of problems like this. If you're having any issues with how to enter these, please let me know. Send me an email or a message on GoFormative.